for the video. All right. So now, good day once more again. Welcome to online session. So today I will be doing Euclidean geometry. I'm gonna do problem solving. Okay. So now let us try to go through these questions, and I'll also once more try to tackle some of the basics. And remember, if you do not understand, raise up your hand. Feel free to ask any question. So let us start with question number 7. It's a continuation of the very same paper, okay? So question number 7, it reads as follows. It says in the diagram below, angle A is equals to 50 degrees, angle C is equals to 90 degrees, A angle BD is equals to 20 degrees, and AD is equals to 5 millimeters, okay? So now here we are given a right-angled triangle, which is ABC. And then we are also provided with two interior angles, which is ABD and DBC. So now they say to us, give the size of angle B angle DC. So this is basically an application of trigonometry actually. So now they want us to calculate the size of this angle, which is B angle DC. B angle DC, meaning they want us to determine the magnitude of this angle over here. Sorry about that. To determine the magnitude of this angle over here. It's 1 mark. So it's very simple. So in order for us to determine the magnitude of this angle, we're gonna use sum of the two opposite interior angles of triangle ABD. So that means to answer 7.1.1, we're gonna say B angle DC is equals to how much? Is equals to angle A plus angle B, and then our reason will be opposite exterior angle of triangle, okay? This is one of the reasons why we say this angle is equal to sum of these two opposite interior angles. And therefore, in this case, our angle A, it's 50 degrees, plus angle B, it's 20 degrees, okay? So now what is the sum of this is gonna be most definitely 70 degrees. That means B angle DC will correspond with 70 degrees. This is the magnitude of the angle, okay? Then we're done for 7.1.1 for only 1 mark. And therefore, we move on to 7.1.2, where it says calculate the length of BC. Now, let's go back to our diagram and look for BC. Now, this is length BC that they are actually talking about. They want us to calculate the length of BC. Now, if you take a closer look at side BC, you can calculate it in 2 different ways, okay? No, actually you can calculate it in only one way, because at some point you're gonna need this side. Now this is what is happening. We have already determined the magnitude of this angle, right? Is 70 degrees. So they want us to determine BC. If maybe we want to utilize this triangle, which is called BDC, most definitely we're gonna want to use the trigonometric functions in order for us to determine BC. But the problem is we do not have any other side where we can say it's fine for us to use trigonometric function, meaning SOHCAHTOA, it won't be applicable when it comes to the angle to solve BC. Please close your mic. So now in that case, the question is now, how are we going to determine that? Now, this is how we're going to determine that. We can most definitely use this triangle, which is called triangle ABD, okay? So now what are we going to do with triangle ABD? We can simply or easily manage to determine side AB using one of the rules. Remember, when you talk about a triangle that do not have 90 degrees in it, if you want the sides of triangle that do not have 90 degrees in it, it's either you use cosine rule or area rule or sine rule, depending on what it is provided at that time. So if we want to use one of the trigonometric rules to determine side AB, we can actually use sine rule. We wouldn't be able to use cosine rule. The cosine rule, we're supposed to be provided with the two sides, and therefore we'll be looking for that side. So that means cosine rule, it is not applicable at all. That means sine rule for this triangle, it is applicable. So we're going to determine AB using sine rule. So that means if we want to use sine rule, we're supposed to know the opposite angle of that side, which is called side AB. That means we're going to have to determine this angle first. So what is the name of this angle? It's A angle DB, okay? So that means we're going to say A angle DB is equals to 180 degrees minus B angle DC. Then what's my reason? My reason is sum of angles on straight line, okay? Sum of angles on straight line. This is the reason why we're saying A angle DB is equals to 180 minus this. And therefore, we're going to say 180 degrees. What is the magnitude of this angle? It is 70 degrees. And therefore, we're going to get how much? We're going to get 110 degrees, which is now this angle. Now, let us determine side AB. How are we going to do that? We're going to use sine rule. So that means we're going to say AB over sine opposite angle to AB. That means sine opposite over sine what? Over sine 110. Sine 110 degrees is equals to, we are provided with this side. That means we have the opposite angle to that side. We can also be able to use this side and that angle while we're using our sine rule. So that means the opposite side, it's AD. So that means you're gonna, or you can just simply substitute it, which is 5 meters. 5 meters divided by sine opposite angle, which is 20 degrees. Sine 20 degrees. And if I'm gonna multiply both sides because I want to solve for AB, I'm going to multiply both sides by sine 110 degrees. That means on this side of the equation, sorry about that, on this side of the equation, I'm going to have AB is equals to, I'm going to multiply by this, which is sine 5, sine 110 degrees divided by sine, where is my pen now? Okay, sine 20 degrees. And therefore, when I punch this on my calculator, I'm going to say fraction 5 sine 110 degrees. Make sure that your calculator, it is in degrees, not radians. Sine 20 degrees. And therefore, our answer will be into 2 decimal places. It will be 13,74 meters because we use the meters as our units. And therefore now, in order for us to answer the question, calculate the length of BC, we have already determined AB. So for a fact that we have AB, in this big triangle, which is called ABC, we can now simply manage to determine the length of BC using the trigonometric functions because we have this angle. This is hypotenuse, since well it's opposite to 90 degrees. Therefore, we're going to use SOHCAHTOA, which is, we are looking for opposite, which is BC. That means sine 50 degrees is going to be opposite, which is BC, over hypotenuse, which is AB. That means we're going to say sine 50 degrees is equals to opposite in this case, which is BC, over hypotenuse in this case, which is 13,74 meters. Yes. And therefore, we cross multiply BC multiply by 1. Most definitely it's going to be BC, which is equals to 13,74 multiplied by sine 50 degrees. Therefore, our magnitude of BC is 13,74 sine 50 degrees. And therefore, I get 10,53 meters. And therefore, this will be a length of BC. I hope that it is clear, which is for 5 marks. Okay, that's how we're going to solve that one. Now, remember, if you do not understand, make sure that you raise up your hand and ask. Now, I continue. As I continue, I'm going to solve 7.2. Now, let's read it together. It says the diagram below shows a regular octagon inscribed in a circle of radius r centimeters. Center O, A, and B are 2 vertices of the octagon. on the circumference of the circle. Now, immediately when they tell you that you are provided with a figure which is an octagon, I understand it is not there, guys, in your curriculum nowadays, but you have to understand your basics of maths from, I don't know, from which grades. So we know that octagon, it is a polygon that has 8 sides. 1, 2, 3, 4, 5, 6, 7, and 8. This is an octagon, okay? It has 8 sides. Now they say to us, 7.2.1, determine the perimeter of the octagon in terms of r, in terms of radius, basically. So now this is what is happening. When they say to you, determine the perimeter, they want you to determine the sum of the sides of your polygon. So that means if we know one side, we know that we're going to multiply that one side with 8, basically, because we know that octagon has 8 sides, okay? So that means we're going to have to determine one side. In this case, most definitely, we're going to have to determine AB. So we're going to determine AB in terms of R because the magnitudes are actually not provided, okay? So now remember, they said to us from the statement, this, what is it? The diagram below shows a regular octagon inscribed in a circle with radius R. So that means the line from center to the circumference of the circle, it is the radius. So that means here we have radius, and that other side, we also have a radius. So that means we're going to have to determine AB. But now, if we want to determine AB, AB is a triangle that do not have what? It doesn't have what? AB. It doesn't have 90 degrees in it. So that means if I want to determine side AB, I'm going to have to use one of the trigonometric rules. Now, this is what is happening. One of the most important part is if maybe I were to draw many radii, okay? If I were to draw many radii, so I was going to have angles around this point, which will most definitely add to 360 degrees. Angles around the point, we know that they add to 360 degrees. So that means in order for me to get individual angle for all of these triangles that I will be managed to form, meaning I'm going to be able to form 8 triangles. I'm going to say 360 degrees divided by 8, okay? That means it's 45. That means each angle over here will be 45 degrees, 45 degrees, 45 degrees, 45 degrees, 45, 45. When we add all of those 45 degrees, which is it's going to give us 360 degrees, okay? So that means this angle over here, it's 45 degrees. Now, in order for me to determine AB, I'm going to use cosine rule. So I'm going to get my AB in terms of R. Now, how are we going to do that? So that means to determine the AB first, we're going to say AB squared is equals to cosine rule. Remember, we use this adjacent sides and this angle which is provided. So that means we're going to say it's R squared plus R squared minus 2 R multiplied by R multiplied by cos this angle over here, which is 45 degrees. If you forgot these rules, guys, please raise up your hand so that I can go back a little bit and try to explain these rules or how do they work, okay? So that means this is how we're going to do it. And therefore, remember, on this side of the equation, we have AB squared. Okay, Nino, raise up your hand. Yes, Nino? Nino? I see your hands. Unmute your mic. Unmute your mic because your hand is up. Okay, you will just project your voice. So R squared plus R squared is going to be R squared plus R squared is going to be 2R R squared plus R squared is going to be 2R squared. And therefore, we're going to have negative 2R multiplied by R is going to be R squared multiplied by cos 45 degrees. And therefore, we're going to say our AB squared is equals to, I'm going to take 2R squared outside because we have 2 terms here separated by this minus. So I'm going to have 2R squared open bracket. Here I'm going to left with 1, and then here I'm going to left with cos 45 degrees. But now remember, what is cos 45 degrees? You can just punch it on your calculator. It's root 2 over 2. So that means here I'm going to left with root 2 over over 2 and then close bracket. And therefore now I'm going to say AB squared is equals to 2R squared. So when I punch this on my calculator, I'm going to say 1 minus my answer is going to be, close bracket, it's going to be 2 subtract 2 over 2, close bracket. And therefore, I'm going to multiply with 2. That means I'm going to have r squared into 2 minus root 2. This 2 will cancel that 2 when I multiply. And therefore, remember here I have AB squared. And then I'm going to get rid of this squared. Both sides, I'm going to introduce root sign. So that means AB in this case will be equals to, remember, r squared is a perfect square. So I'm going to have r into root of 2 minus root of 2. And therefore, this will be the magnitude of AB. But remember, the question wanted us to determine what? To determine the perimeter of the octagon. So now we know the side AB. So we're going to multiply this side of AB by 8 because sum of the sides of our octagon will give us the perimeter of the octagon. So that means we're going to say the perimeter will be equals to 8 multiplied by AB. In this case, we're going to say it's 8 multiplied by AB. It's R root 2 minus root 2. Therefore, our final answer will be 8R root 2 minus root 2. Therefore, this will be our perimeter of the octagon. So any question regarding this? Okay, I believe we all understand it. Right. That means I move to 7.1.2. Oh, I do not have enough space. So that means I move to 7.1.2. 7.1.2, it says to us, show that the area of the octagon is given to be this. Basically, oh, do not forget to write your units here. Remember, it was given in centimeters here. So that means here our final answer will be in centimeters, just like that. Okay, so don't forget to write your units. Your units are very, very important, guys, because I've realized that some of the people, they tend not to write the units. So I'm gonna mark you wrong there when I mark at examination center. So I'm gonna mark you wrong. So now here it says to us 7.2.2. It says to us, show that the area of octagon is provided to be this. Okay, so now let's go back to our octagon. They want the area of the octagon. So I said to you, if I were to draw the radii, oh my God, oh my goodness, you're gonna have to forgive me about that. If I'm gonna have to draw the radii here, I have how many triangles? 1, 2, 3, 4, 5, 6, 7, and 8. That means I have 8 triangles. So that means sum of the area of these triangles will give me the area of the whole octagon. So that means, again, I'm going to determine area of one triangle. And then after me getting the area of one triangle, I'm going to times it by 8. That me timesing the area of this triangle by 8, that means it is the area of the whole octagon, okay? So that means area of the whole octagon will be equals to how much? So we're going to say area of octagon will be the same as 8 area of triangle, okay? So now that means here we're gonna have 8 multiplied by area of triangle. So let's work with only one triangle. Basically, we're gonna work with this triangle. Now remember, what did I say to you? I said to you, if you are given triangle like this, whereby there is no 90 degrees in it, you're not going to use that formula that says half base multiplied by height. We know this is the formula that we use to calculate the area. But we use this formula only if triangle, it has 90 degrees in it. Here, there is no 90 degrees. So that means we're going to use the area rule to determine the area of this triangle. So that means the area of this triangle is going to be equals to how much? It's going to be half multiplied by adjacent sides. Do not forget that. Multiply by adjacent sides of an angle, multiply by sine theta. Our sine theta will be that angle that is adjacent to these two sides, which is 45 degrees. And therefore, we close the bracket. Okay? So that means let us work this out. So that means I'm going to have to multiply this here together. So I'm going to say 8 multiplied by half is going to be most definitely 4 multiplied by r multiplied by r. It is most definitely r squared. And therefore, what is sine 45 degrees? Just punch it on your calculator. It's going to be root 2 over 2, okay? Multiplied by root 2 over 2. This will be sine 45 degrees. Now, remember, we have already determined the magnitude of R of R. We have already determined the magnitude of R. No, we haven't. Okay. So now here we have 4, we have R squared, we have this over that, and therefore, let's continue by multiplying. 2 goes how many times into 4? It goes 2 times. So I'm just going to utilize this space over here, okay? Just going to utilize this space over here. So 4 multiplied by this is going to be how much? It's going to be 2. I'm continuing. It's going to be 2 R squared multiplied by what? Multiplied by root 2, okay? And therefore, now let us rearrange this the way they want it to be. So I'm just going to write this 2 over here, and then this root 2 over here, and therefore the r squared, which is this, I'm going to take it to other side of the expression and just write it over there in centimeter squared. And therefore, this is how we determine the area of an octagon. Do we have a question? That means I continue. All right. Now, question number 8. It says to us, give reasons for your statement in question number 8 and question number 9. Okay. So 8.1, it says to us, in the diagram below, A, B, C, and D are points on the circumference of a circle, center O. AC and DB intersect at E, which is 2. AB is parallel to DC. It's also indicated on the diagram. B, angle OC is equals to 90 degrees. B, angle OC. Basically, they are talking about this angle, that B angle OC is equals to 90 degrees. 8.1.1, it says to us, determine with reasons, 3 angles equals to 45 degrees. Right, for 3 marks. 8.1.1. To determine other 3 angles with reasons that are equals to 45 degrees. Now, we are given the magnitude of only this angle. So this is what I want you to take note of. This angle that we are provided with, it is the angle at the center. Now, if you have a look at diagram BDC, you will understand the theorem number 2 from grade 11. So that means we're going to apply that theorem to solve this angle, since well, we are provided with the magnitude of this angle to be 90 degrees. So that means B angle DC, it is half of B angle OC. Normally, this is how we write it. We're going to say B angle OC is what? Is twice B angle DC. Why do we say this angle is twice this angle? It's because angle at center is twice angle at circumference, at circum. Okay? Therefore, what is B angle OC? The magnitude of B angle OC, it is provided to be 90 degrees, is equals to 2B angle DC. Therefore, we divide both sides by 2. That means B angle DC will be equals to 45 degrees. This is the first angle that is equals to 45 degrees. Now, the second angle, which is equals to 45 degrees, it is this angle over here. Okay, why? Because these are the same angles in the same segment. So that means we're gonna say angle A is also equals to 45 degrees. But remember, in Euclidean geometry, you're supposed to give your reasons. Why do you say this is also equals to 45 degrees? Angles in same segment. Just gonna write segment. They're in the same segment. Okay, so this is the second angle, which is equals to 45 degrees. And once more again, we have the parallel lines. We know that within the parallel lines, we have the corresponding, we have the alternating, we have the co-interior angles. So that means for a fact that we have formed Z shape. So that means this angle will be equals to this angle. They are alternating within the parallel lines. So that means angle B in this case will also be equals to 45 degrees. But what is our reason? The reason is that we have the alternating angles. Since well AB is parallel to DC, you write it down as your reason. We have the alternating, or we can say equal angles due to alternating angles, since well AB is parallel to DC, and this will be the third angle that is equals to 45 degrees. And I hope that it is clear now. And then there we also have 45. Just write it like that. Okay. That will be 8.1.1. Now, 8.1.2a, it says to us, hence, prove that, I've seen, guys, a lot of people, they struggle when it comes to proving. Hence, prove that CE is equals to DE. Where is CE? Go to your diagram and locate for CE. This is CE, okay? You're gonna have to prove that CE is equals to DE. Now, all the time, check, this is a triangle to start with, and they want you to prove that this opposite side of this triangle are equal. All the time when they tell you that, always think of the base angles. We talk about an isosceles triangle. So with an isosceles triangle, the base angle is supposed to be equal. So that means in this case, for a fact that we know that the angle here is 45 degrees, let's make means of determining this angle, and we're supposed to get this angle to be 45 degrees. So if these two base angles are now equal, it is easy for us to say now CE, which is this side, is equals to DE, which is this side, because of the base angles are equal and isosceles triangle principle. So that means let's determine E angle CD. So we're gonna, I'll just call it C. So we're gonna say angle C is equals to 45 degrees. But why do we say that? Because again, you can use the alternating angles within the parallel lines, or you can use the angles in the same segment. So I'll just say same segment. So I'm just gonna say angle C is equals to 45 degrees. Why? Because we're talking about angle in same segment, okay? In other words, that means this is also 45 degrees due to this angle, or you can say alternating angles within these parallel lines, it is still fine. And therefore, now you can simply say CE now is equals to DE. Why did we say that? Because we proved that base equal base, because we have equal base angles. This is one of the reasons why we say CE is equals to D. It's because of equal base angles. Or some I've seen they write isosceles triangle. Okay, so that means this is how we're gonna solve number 8.1.2a, proving that CE is equals to DE. That means I move to the second question, which is B. Now B, it says to us, CD is the diameter of the circle passing through ECD. Aha, they say CD or DC. CD, it is a diameter, but it is not the diameter of this circle. It's a diameter of which circle? A circle that passes through ECD. That means we have imaginary circle. But to make things much more easier, we're going to have to draw that imaginary circle. So they say, let me use a different color. Let me use different color here. I'll use the blue one. So we have points ECD. So this is point E they are talking about. This is point C they are talking about. And this is point D they are talking about. And therefore there is an imaginary circle that is going to pass through these points. There is an imaginary, I'm sorry about my circle though. There is an imaginary circle that's going to pass through all of these points, okay? And do not forget here we have CE here. We have CE here. And then we have DE here. Do not forget that, okay? Do not forget that, okay? We have that. Now, this is what is happening. In order for us to prove that, in order for us to determine that, let me use this one so that we can remind ourselves what is basically taking place here. Okay? Now, we have just proved that this angle is 45 degrees. This angle is also 45 degrees. Or we can use this triangle. We just say this is 45 degrees, this is 45 degrees. So we're going to determine the magnitude of this angle over here. It's going to be 90 degrees because this is 45, 45. So remember, these are the basic. We proved they are equal. So that means sum of angles in a triangle, they add up to 180 degrees. So 180 degrees minus 45 is going to be 90 degrees, which is this 90 degrees, okay? So now that means in this triangle, we're going to have to determine that. Okay, let me use this one actually. So 8.1.2b, 8.1.2b, look, we're going to determine the magnitude of this angle, okay? We're going to say, let's mention the triangle. In triangle DEC, what is happening in that triangle? This is what is happening. Angle E is equals to 180 degrees, subtract this 45 degrees that we have proved already, subtract this other 45 degrees that we have proved already. Why do we do this? Because we're talking about sum of angles in a triangle. So that means 180 minus 45 is going to be 90 degrees. That means angle E in this case is going to be 90 degrees. Now, remember, I drew a circle around those points that they have mentioned. And then they said we have to prove that CD, it is a diameter to that circle, which is the blue circle. So that means, remember, one of the principles that angle, which is 90 degrees, will always be subtended by a diameter in a circle. Okay, so meaning this is the reverse of that theorem, which is, I think, is theorem number 3, grade 11. So that means we're gonna say, therefore, DC is DC, or they say, let's write it the way they wanted, CE, CD. Therefore, CD is the diameter. But then, how did you prove, you write it here, how did you prove that CD is a diameter? It's subtended by 90 degrees. That's why we proved that CD is a diameter. It's a converse of theorem number 3. Okay, I hope that was clear. I hope that was clear. Feel free to ask where you do not understand. Simple as that. Right. So now let us try to solve question number 8.2. 8.2 says to us, in the diagram below, A, B, C, and E are points on the circumference of a circle. BC produced meets AE produced at D, AB is equals to AC. It is also indicated on the diagram that these sides are equal. Angle D is equals to 35 degrees. It is also given, it is also indicated there. Angle A1 is equals to 40 degrees, also indicated there. Now they say to us, determine with reasons, number A, angle C1. So that means we're gonna do 8.2.1A, okay? They want us to determine the magnitude of angle C1 for only 2 marks, most definitely giving reasons. Now let's have a look at C1 where it is located. This is where C1 it is actually located, okay? Again, the very same thing that we talked about here, it's going to apply here as well. Not here, I think it was on previous question where we have the radii. So now you are told that, literally, you are told that AB is equals to AC, right? If that is the case, that means these two angles, these two base angles, supposed to be the same because the opposite sides of triangle ABC are equal. That means these two angles are also equal. Okay, so that means angle, this angle, which is ABC, I will also call it angle C1, and this is also C1 because they are equal. So in order for me to determine angle C1, I'm going to mention my triangle that in triangle ABC, what is happening in that triangle? What is happening is that, I'll write it like that, angle 40 degrees plus, remember I said this angle is equal to that angle. So that means this angle, I will also call it C1. In this triangle, angle C1 plus angle this C1 is equals to 180 degrees. Why? Because it is the sum of angles in a triangle. And therefore, I'm going to transpose 40 to the other side of the equation. That means I'm going to have 140 degrees because it's going to be 180 subtract 40 degrees. And therefore, C1 plus C1 is going to be 2 angle C1. Oh, I'm running out of time. I have less than 1 minute. And then I divide both sides by 2 angle C1. In this case, it's going to be how much? It's going to be, I think it's going to be 70 degrees. Yes, it's going to be 70 degrees. Okay. So let me do another video because I have less than 1 minute. So reschedule another new meeting. So this is how we determine it. So let me do another meeting. Yeah, it's gonna cut anytime soon. I want it to cut by itself.